In this video, I want to talk about the graph, domain, and range of an exponential function. So we haven't talked too much about the domain and range of exponential functions, so we'll do that in this video, but we'll also do an example of graphing an exponential function. So this is an exponential function that's a little bit complicated, but not too bad. Let's go ahead and start by doing a chart, but before I do that, let's just think about it. So a 1/2 to, it's positive, right? So it's going to be up here like this. But a 1/2, anytime we have a fraction to a power, it kind of reverses direction, right? So it gets bigger when the exponent gets smaller or gets more negative, and it gets smaller when the exponent gets more positive. So it's going to be like this. And then it's going to be, this is going to be a shift down to, and then this is going to be a shift, the opposite of what we would think this is going to be a shift, not down 2 units, up 2 units. Sorry about that. This is going to be up 2. And this shift is going to be the opposite of what we would think it would be. So we are going to go to the right 1. So let's just keep that in mind. So, but we can go, so if we think about that shift, we can remember that to go up 2, we're going to have our asymptote at 2, at positive 2. So let's go ahead and do that. Let me make that better, asymptotes. Okay, and that was right 1. And so if we go to the right 1, we usually cross through at like 0, 1, which here would be 0, 3, but it's going to be to the right 1. So this point should be on our graph. And we should be kind of going like this. But let's go ahead and plot some points just to be sure. Oops. We can go ahead and do -2, -1, 0, 1, and 2. Although now that we're moving to the right 1, we might also want to do 3. So I'll go ahead and put that in there too. So -2, when we put this in, -2 is going to become -3 in our power. So 1/2 to the -3 is going to be 2 to the 3rd, which is 8, plus 2 is 10. -1 is going to become -2 in the power, and 1/2 to the -2 is 2 to the 2, which is 4, plus 2 is 6. 0 is going to be -1. 1/2 to the -1 is the same as 2 to the 1st, so that's going to be 2 plus 2 is 4. 1 is going to be 0, so this is going to be 1/2 to the 0 power, which is 1, plus 2 is 3. 2 is going to be 1 here in the power, so 1/2 to the first power is just 1/2, plus 2 is 2.5, so 2.5 I'll say. 3 here is going to give us a power of 2, which is going to be 1/4, so it'll be 2.25. So if we go ahead and graph these points, we have -2, positive 10, so 1, this is 3, 4, 5, 6, 7, 8, 9, 10, and then -1, 6, so this is 2, 3, 4, 5, 6, 0, 4, and then this is what we expected, 1, 3, and then 2, 2.5, and 3, 2.25. So our graph is going to look, that was terrible, graph is going to look something then like that. And let's think about now our domain and our range. So for the domain, it goes off to infinity, but any value, you can put in any exponent you want, right? There's no restrictions on what exponents you can put in. So the domain is from negative infinity to infinity, and that's typical of all exponential functions, unless something really strange is going on, like a fraction in the exponent could be a possibility, but typically the domain is negative infinity to infinity. The range, we need to look at our asymptote. So we don't cross through our horizontal asymptote, and so we're going from here to all the way up to infinity. So we're going from 2 to infinity. Now we need to ask ourselves, is there a bracket or a parentheses at 2? So does it actually ever reach 2? Well, it gets infinitely close to 2, but it never reaches 2, so it's a parentheses. So this is our domain and this is our range, and that's how we find the graph and the domain and the range of an exponential function.